Okay, people, it's Mrs. D. After reviewing a whole bunch of software, I have figured this out. So for your windy tunnel activity, you are no longer going to follow this link. In your assignment, I have posted the new link, which is this one. This is the NASA website, the FoilSim software. So unfortunately, due to the death of Flash Player, we cannot use this one. However, we're still going to be testing these same airfoils. So we're going to test a symmetric airfoil at 0 degrees, 9 degrees, and 18 degrees. And then we're going to test a cambered airfoil at 0 degrees, 9 degrees, 18 degrees. And I've also posted this in your assignment. So before you do this, I would like you to take a look at the windy tunnel exercise. I don't expect you to complete the math in this worksheet, but I would like you to read here about these things, about speed, vertical velocity, lift, and power. So I'd like you to read this and understand kind of like air density and angle of attack and what those things are. So I'd like you to read through this assignment, or this, I guess, like worksheet, but I don't actually expect you to be able to do these calculations. It's kind of like information for later, but I do want you to look at the example here. Once you've read through that, then you can check out the assignment, which is windy tunnel. Then again, reminder, we're not going to this link anymore. You're going to go to the NASA link provided in your assignment, and the simulation is still going to show you velocity lines of airs running over the wings. Lines that are closer together show fast moving air that causes lift. And it also has like a little chart that shows you lift and drag. In this table on your paper copy, this is where you're going to fill in your results. You'll tell me symmetric 9 degrees, 18 degrees, and then cambered 0, 9, and 18 degrees. And then you're going to comment here if the shape has no lift, if it has lift, or if it will stall. So to determine the answer to those questions, I want you in the assignment to watch this tutorial video, but then also I would like you to watch, how do I get over there? Here we go. This video. So this one here shows the streamlines on a lifting airfoil. And if you watch it all the way through and you watch the lines, it shows you how to tell when the plane's going to stall. This is just really shows. So it shows increasing the angle of attack. So as the angle goes up, you can see that these lines start to, like here, they're still staying together. And here, they're really close together, which indicates lift. Here, they're starting to separate. And we're getting this gap in here. This is where, just wait. Like, see here how the lines aren't rejoining anymore? This is where we start to lose lift, and consequently, we end up getting into a stall. So I want you to watch this and just watch the lines and kind of be able to interpret that information, because when you go to test on this link, so let's start with kind of walking you through this. You want to make sure that you're on the shape tab, not the flight tab, but the shape tab, and you want to be testing an airfoil. It defaults to shape and airfoil, but just please make sure that you're there. And then you'll be first testing angle 0, camber 0, and the shape is symmetric. So with symmetric, angle 0, camber 0, you can look at the lines here and you can see the simulation. Also, you have this table with lift and drag. If you want to compare your results, rather than like opening a whole bunch of windows and comparing them, you could also take a screenshot or take a snip and then compare your images after, which is what I did. I just took a whole bunch of pictures. So the next you're going to test symmetric at 9 degrees, and like you can either click repeatedly or you can just drag over to 9 degrees and then watching the lines as they go. So like approximately 9 here, you can see here the lift is increasing and then the drag has decreased. So it's important to note the lines and note this information. And then again, going all the way up to 18. And then also once you change from symmetric to chest, high camber. And high camber, just make sure you start this at 0. So starting at 0, log this information, and then going to 9, log the information, and then going all the way up to 18, and then logging that information. Then again, watching these airlines and referring to the video here to determine if you're going to stall. So once you've gained all that information and you've filled out the table, again, so symmetric 0, 9, 18, and then camber 0, 9, 18, then you can answer the following questions. So which airfoil shape and angle caused the most lift? And then you can go back on those tables and see. And then which airfoil shape caused the plane to stall? So this information is what I would like you to do today. You're going to be doing this independently, and you're going to be filling it out on paper and then handing it in to Mr. Withrow by 11. If you finish early, you can start looking at your airfoil selection. So there's 2 attachments that I put on the assignment. The first one is designing your wing. So you're going to want to read through here some of the technical terms you might want to understand here, like reading through this, and there's a whole bunch of really great resources here. And then we're going to be looking at the Airfoil Tools website. So if you want to like open that up and check it out, you can also check out the other link or PDF I posted, which is airfoil selection. I don't actually want you to do this today. I just want you to start looking through it because this is what we're going to be doing next week. So you can start looking at the Airfoil Tools website. You can start scrolling through and start looking at some of these things because this is what we're going to be doing. And then you may want to consider picking a partner for this project. And this is going to be your long-term partner for the next 10 plus periods. So pick someone that you think you'll do a good job of this project with. That's it. So this is your assignment for Friday, is to complete your paper windy tunnel activity using the website and watching this video. You can probably disregard this link now because Flash is dead. And then once you filled out your paper, hand it into Mr. Withrow, and then you can start looking at your airfoil selection. And then if after today you're like, what's an airfoil? I don't understand. I'd really like you to go and read some of these resources that I'm sharing with you so that you do understand some of the terminology. Any questions, comments, or concerns, please ask Mr. Withrow or message me on Teams. Have a great day.